in the second half of that delta math, we'd asked you guys to basically work on going and using the unit circle kind of in reverse, right? Where we start with the value for sine, cosine, or tangent and try to work backwards to get the angle, or angles, right? What I want to do today to start is kind of elaborate on that a little bit more. So we're going to kind of be working in that same line of thinking. So let's say we start with like our graph of sine. So this is just y equals sine x. Okay. If I want to find out where sine x is equal to 1/2, well, 1/2 is like right about here on the y-axis. So I have like a solution here, another one 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 there. And how many are we talking about in total? Solutions. Infinitely many, right? Because the thing just keeps on going and going and going. What we'd like to do is we'd like to create a function that we could program into our calculator that would help us, compute sine inverse so we don't have to go to a graph. If you remember from last year, to make an inverse, we can take our graph and reflect it across the line y equals x. So if I take my graph of sine and reflect it across the line y equals x, I get this bold face graph right here. What's the problem with that graph, though? Why would we be unhappy getting that graph if our goal is to create a inverse function we could type into the calculator? What's wrong with this graph? There's a problem with it. That's not the issue. That's not the issue. Not the issue. Well, let me ask you this. If I look at that graph, the bold-faced one, is that a function? No, why not? Very good. It fails the vertical line test, right? Everybody, you vaguely remember that from last year? That's a thing you would have talked about. So what do we do if I have, a function whose inverse is not a function, right? Like we do in this situation. What we do is we take our original function, we restrict its domain. So say, okay, I'm going to just take the part of my original function that goes from this minimum to this maximum, and then I'm going to throw everything else away. So if I use just that little part of my domain, and then I create my graph of my inverse, I get this bold-face graph. What did you notice about this one? Is that bold-face graph a function? Yes, right? That passes a vertical line test. We're all good. What's the drawback? Well, it doesn't have its domain and range are restricted, right? So we're going to call this graph sine inverse. That's the same sine inverse function that's programmed into your calculator. The domain for sine inverse is -1 to 1. And the range, the outputs, it'll only give me angles between -π/2 and +π/2. We could do the same process for cosine and for tangent. God bless you. Okay. So remind me again, we've written down some domains and ranges here using interval notation. Some of those domains and ranges have brackets around them, some have parentheses. Remind me again, what's the difference between using a bracket and using a parenthesis? What is the difference? They mean the same thing, the bracket and parenthesis, when we're writing an interval notation? What do you guys think? Yes or no? No, they don't mean the same thing. What's the difference then between them? What does a bracket mean and what does a parenthesis mean? Yeah, Aaron? Not exactly the number of solutions, because what that interval is it's a set, right? It's a list of values. But the bracket and parenthesis means something different with the values that are in that set. Does anybody remember? So the bracket is like your or equal to inequality. So what that range there is saying for sine is all the numbers between negative pi over 2 and positive pi over 2, including those endpoints, as opposed to tangent, where the parenthesis means like a strict inequality. So the set parenthesis negative pi over 2 comma pi over 2 parenthesis means all the numbers between negative pi over 2 and pi over 2, but not including those endpoints. Is everybody okay with that? Bracket including, parenthesis not including. So far, so good? So when you guys, we've used these inverse commands on our calculator, right? Particularly in chapter 2 when we were solving triangles, right? We did that. The catch with that, though, is that those inverse commands will only give us back certain angle measures. So let's look at doing a couple of examples here now. All right, so example 1 says find the exact value of sine inverse of negative 1/2. When you're in a math class and we ask for an exact value and the problem involves a sine, cosine, or tangent, what do we know we're going to need to be using? Our main tool for looking for an exact value, and it's involving a sine, cosine, or tangent, should tell us we're going to need to be using our unit circle. So if you don't have your unit circle handy still, I have a bunch of copies on the top of my file cabinet over here. You're welcome to come and grab one at any point if you still need one. But we should ideally still have that.
So, where is it?
On top of the file cabinet over here. You're welcome to grab one if you don't have one. You'll need one for your homework, so. All right. To use to use this unit circle now. I know sine is y on the unit circle. So I'm going to be looking for the places where the y coordinate is -1/2. So if I go and I look at my y coordinates, I see a y coordinate -1/2 there, and a y coordinate of -1/2 there. So far, so good. So my solutions appear to be 7 pi over 6 or 11 pi over 6. Is everybody okay there? The problem is that I know that the range for sine inverse is -pi/2 to +pi/2. So I need to look at my two answers. Is 7 pi over 6 in between -pi/2 and +pi/2? If you have trouble seeing it with the fractions, let's pull the pi's off. So 7 pi over 6, let's just call 7/6. Is that between -1/2 and +1/2? No. Is it too big or too small? Too big. How about 11 over 6? Is that in between -1/2 and +1/2? No. Is it too big or too small? That's also too big, right? Does everybody feel okay so far? So neither of these two answers, 7 pi over 6 and 11 pi over 6, are correct because they're not inside of the range for sine inverse. They're both too big. So what we're going to do is find an angle that's coterminal to them and see if that angle lies inside of -pi/2 to +pi/2. Since they were too big, we are going to be subtracting, and then because we're looking for a coterminal angle, it's going to be 2 pi, right? 2 pi is 360 in radian speak. So I'm going to do 7 pi over 6 minus 2 pi. In order to subtract those two numbers, what do I need to do? Well, let's say do it by hand. If I want to do it by hand, what would I have to do? Great, I need to make a common denominator, so I'm going to think about 2 pi as 2 over 1. What would the common denominator be between 7 pi over 6 and 2 pi over 1? 6. So I'll multiply 2 pi over 1 by 6 over 6. And then how do I subtract the two fractions once I've made a common denominator? It's like a 5th grade question, guys. How do I subtract the two fractions now that I've made a common denominator? Subtract the numerators. So 7 pi minus 12 pi is? Close. -5 pi. And what's the denominator? 6. Everybody okay there? Okay, so now I'll ask myself, is -5 pi over 6, is that between -pi over 2 and +pi over 2? Lucy's shaking her head. No, that's correct. Is it too big or too small? Too small. So this answer is out altogether. Not going to work. Let's do the other one. So 11 pi over 6. And I'm going to just write, instead of minus 2 pi, I'm going to write it as 12 pi over 6. Since we've already gone and made the common denominator, we know how to do that. So there I get -1 pi over 6. is negative 1 pi over 6 in between negative pi over 2 and positive pi over 2? Yes. So that's my answer, is negative 1 pi over 6. So it's just like what you did yesterday with the added step of now we might have to add or subtract 2 pi's to get the answer in the desired range. Does that feel okay to everybody? Okay. So you'll be doing that on one part of your homework assignment, is that same kind of a problem. Bless you. So our next one says evaluate sine inverse of negative 0.32 using a calculator. So even if I didn't have the calculator instruction here, I should be able to look at this and know from looking at the problem that this is going to be a calculator problem. What in here is telling me that this will be a calculator problem? The what? Yeah, the fact that negative 0.32 is not a unit circle value, right? So again, our unit circle numbers are like 0, a half, root 2 over 2, root 3 over 2, 1, or some combination of those where you're doing division, right? So far, so good? So all I'm going to do, I'm going to take my calculator, press second and the sign button, type in negative 0.32, and I get negative 0.326. If you have your calculator with you, why don't you try typing that in as well and seeing what we get. If you don't get the same value I did, you get like 18 something or another, what's the problem? You're in the wrong mode. Very good. What mode should we be in for this problem? The other one. Radians. Yeah, if you got 18, you would have been in degree mode. We need to be in radian mode. So if you change your calculator to radian mode and try it again, I bet you get the right result.
How do you change it?
So the mode button is right next to the blue second button. And then you just highlight the option that says radian and press enter, or rad, or whatever it says there. Everybody feel okay? All right. Let's look at a slightly more complicated version of this same kind of problem. So here it says solve for theta, and we have sine theta equals negative 0.32, and our answer for theta needs to lie between pi over 2 and 3 pi over 2. So what we're going to do is we're going to start by drawing a picture of what our solution is going to look like. So I'm going to make myself an XY axis. And if I look at my inequality, it's telling me that my answer for theta is going to be positive, right? So I know when I'm graphing, drawing like my standard position angle, and my angle's positive, I'm going to be going counterclockwise. So I'm going to start here, and I'm just going to count by each quadrant. So remember, 90 degrees is the same thing as pi over 2. So I'm pi over 2, pi, 3 pi over 2. And there we go. So I know that my answer needs to be somewhere here between pi over 2 and 3 pi over 2. So in either quadrant 2 or 3. So far, so good? Secondly, from this, I can see that sine is negative. So if I do my all silly turtles crawl, I know sine is negative in quadrants 3 and 4. Is everybody okay with that? Okay. So my answer, the terminal side of my angle theta, needs to lie in quadrant 3, where both the inequality and the sign for sine hold. Right? That's the only place where sine is negative and it's between pi over 2 and 3 pi over 2 is quadrant 3. Now, the place where I put the terminal side of my angle theta doesn't really matter as long as it's in quadrant 3 somewhere. Doesn't need to be right in the middle or whatever. Just get it in there, get it in the right quadrant, and we're going to be okay. Everybody so far so good? I'm now going to define another angle. So the other angle I'm going to define is, let's use a different color. I don't like this color. It's hard to see. Do this. Is here between the x-axis and the terminal side. I'm going to call that angle alpha. Okay, so alpha is always between the x-axis and the terminal side of theta. And the way we're going to find alpha is going to be always the inverse function of the absolute value of our problem. So we're going to be sine inverse the absolute value of negative 0.32. Always the same way. Always between the x-axis and the terminal side. Always between the x-axis and the terminal side. Always between the x-axis and the terminal side. Everybody feel okay? Now we're going to go ahead and write an equation to solve for theta. So theta is always going to equal, well, I shouldn't say always. When theta is a positive number, my solution is going to be the piece of the x-axis that makes up alpha. So in that case, it's going to be pi. And then I'm going to look at which axis does theta cross on the last axis theta crosses on the way to its terminal side. So in our case, it's the x-axis. So because it's the x-axis, that tells me it's going to be addition. And then it's alpha. So the equation for theta that I'm going to write, whenever theta is a positive number, is going to be the x-axis that makes up alpha, and then it's either going to be plus or minus alpha. If the last axis I cross is the x-axis, it's plus. If the last axis I cross is the y-axis, it's minus. So now that I've got my equation, I'm just going to go to my calculator, and I'm going to do pi plus sine inverse. And to get the absolute value, I can press the math button, go to the NUM option, that stands for number, and pick ABS, that stands for absolute value, and then type in my negative 0.32, and then press enter. Now, I acknowledge that we don't need our calculator to do an absolute value, right? Gosh, I hope not. And in the future, am I going to type in an absolute value when I enter in my calculator? No, man, I'm just going to do that in my head. Now, I'm always going to write the absolute value on my paper, but I'm going to, when I type it in my calculator, I'm just going to do the absolute value part in my head. Right? What does the absolute value do?
Flips the sign.
That doesn't flip the sign. Makes it positive.
Always.
Always. Because an absolute value is just a distance. That's the definition. It's the distance from that number to 0. So a distance is always a positive. So it always makes it positive. If it's already positive, it just stays positive. Mm-hmm. Now, we said our answer is 3.47. Let's check that. Every single one of these problems like this is checkable, but the check is 2 steps. So I have to do 2 things to check this. Yeah, Tia? Sure. The good news is my calculator is going to do all the checking for me. So the first step of my check, I'm going to take that 3.47 and plug it into my original problem and see if I get negative 0.32. So I'm going to do sine of my answer. So I'll press second and the negative sign, and that'll get the ans option. Press enter. That looks good, right? That's what we hope to get. So that's 1/2 of our check. The other half of our check is that this 3.47 has to be in between pi over 2 and 3 pi over 2. Okay, well, pi over 2 is just 1.57, so we're bigger than that. And 3 pi over 2 is 4.71. We're smaller than that. I'm satisfied that our answer is correct because it is a solution to our equation and falls between the 2 values that were given, or falls within our interval. Does everybody feel okay? Let's do that again. We're going to do 2 more examples just to be sure that we got it. So far, so good, though. So I'm showing you this way of doing this because it is, we can do it the exact same way, like every single time. So I acknowledge there are some problems where it could be shorter to do this a different way. But if we do it this way, there's only one way to do it, right? You just do it the same way every single time, and it'll work every single time. And I prefer those methods, like the always works method, than the, oh, this works if it's kind of like this, but if it's like that, then you have to do something different. If it's like that, oh, we should do something, like, give me the one where it's like the same the whole time, right? That's my preference. That's what I'm giving to you guys, is I try hard to come up with a way that it's kind of always the same. So again, I'm going to start by drawing my picture. So let's start our answer is positive, so let's start counting around. So 0, pi over 2, pi, that's the start. 3 pi over 2, and then back to 2 pi. Notice that when if I go around my axis again, when I get to a value I've already written down, I'm going to cross it out and write the new value in. Everybody see me doing that when I crossed out the 0 and put the 2 pi there? Important that you're doing that because when we write our equation for theta, those numbers on the axis are one of the numbers we use to do that, right? So make sure that we're updating. Here I notice that cosine is positive. So if I use my all silly turtles crawl, cosine is positive in quadrant 1 and 4. Everybody feel good there? So my value for theta has to be in quadrant 4. So far, so good. Now I'm going to draw in my alpha. Remember, alpha is always between the x-axis and the terminal side. So there's my alpha. So far, so good. Now we're ready to write our equation for theta. So I'm going to look at first the part of the x-axis that makes up alpha. So that's 2 pi, right? Then we're going to look at which axis theta crosses on its way to the terminal side. The last one that is the y-axis. That means that we're going to be subtracting, and it's always alpha. Is everybody okay? So again, reminder, the picture is what I need to be able to write this equation correctly. Without the picture, I can't do it. Right? The picture is what gets me the equation. Always follow the format we've described. Unless the answer is negative and then it's just kind of like flipped. We'll do a negative one in a second. So I go to my calculator now. Bless you. So 2 pi minus alpha. So cosine inverse of 0.32. Mr. Kulik, what happened to the absolute values? Just did it in my head. Not going to type it in the calculator anymore. So I get 504. But let's check that, right? So to check that, the first thing I do is I plug my value for theta back into the original. So do cosine of that answer and make sure I get 0.32. I do. And then I'll make sure that 504 is between pi and 2 pi. Well, pi is 314, so we're bigger than that one. That's good. And 2 pi is 628. We're smaller than that one. So we are all set. I usually write 2 checks because you have to do 2 parts of the checking. What do you guys think? Is this so far so good? Bless you. And then I want So here we have tan theta equals 2.16. Yeah, sure. Where theta is between negative 3 pi over 2 and negative 1 pi over 2. This part is really important here. What do you notice that's different about this part than the previous ones? My answer is going to be a negative number. If it has to be between negative 3 pi over 2 and negative 1 pi, I have to be getting a negative number. So remember, when we draw our standard position angle, which way do we go if it's a negative value? We go clockwise, right? So negative pi over 2, negative pi, negative 3 pi over 2. So we're looking at quadrants 2 and 3. I observe that tangent is positive. Yeah, sure. So I know that we're either in quadrant 1 or 3. Everybody feel good so far? So where's my terminal side at? Quadrant 3, right? So there's my theta. Next, we're going to draw the alpha. So alpha is going to be tan inverse, absolute value, 2.6. And I'm ready to write my equation for theta. So theta equals the x-axis that's part of my alpha is negative pi. So that part stays the same. And then I look at which is the last axis I crossed before I get to alpha. This part is different. The rule, if my answer is negative, is the opposite of what it was when it's positive. So when it was positive, x meant x-axis was plus, y-axis was minus. They're flipped if my answer is negative. So y-axis means plus, and x-axis means minus if it's negative. Oh, sorry. Y-axis meant plus. I said it and then I didn't write it. Ay, ay, ay. All right. Calculator time. So negative pi plus tan inverse. And I'm doing the absolute value, 2.6 in my head. Oh my gosh. And I get negative 1.94. Let's check real quick. So I do tangent of that answer and make sure I get 2.6. I do. And then let's check to make sure that it falls in the range. So negative 3 pi over 2 is negative 4.71. So negative 1.94 is bigger than negative 4.71. Right? Just how like negative 1 is bigger than negative 3. I know that's confusing sometimes. Yeah, Aiden.
May I please use the restroom?
Yeah, man. Why don't you just go when you got your drink, though?
I didn't have to.
That's a excuse my daughter, who's 5 years old, would have given me. And then I got to check to make sure that the negative 1.94 is smaller than the negative 1.57, which it is. So we're good. Okay. Questions over what we've done here today? Was this okay? I tried to go pretty slow and explain what we're doing, tried to be really thorough, did a bunch of examples. This is where we're stopping for today. So I have 2 worksheets for you guys. The first worksheet, you're just going to be doing like what we did on that very first example with the unit circle. The second worksheet is going to be looking at what we did on these last 3 examples where we drew the pictures. Okie doke? All right. So the Delta Math is due this Sunday. Because we don't have another class day before Sunday, these 2 worksheets will not be due till the following Sunday. Okay? Yes, Jamie? Sure.